Hello, my name is Darren Thomas and I am the Director of Educational Research Techniques. This is easier. Practical applications of machine learning algorithms in R. And so we are now in Unit 5, Lesson 4, and we've been looking at classification using support vector machines. And in this particular video, we're going to focus on using the Radial kernel, and we're going to develop and test the model as we have done in the past. So let's move over to RStudio. Now, when we're talking about a Radial kernel, essentially we're talking about, let me go over here, where we can now have, lines that are curvish. When we were using the linear kernel, the vanilla dot, it was just a straight line that it could form. Now we can do things with curves and twists and turns. And of course, radial kernels is much more complicated than that, but for our purposes, this is enough you need to get started. And I would always encourage you to look at online resources for more information. So, and now also I need to mention that you still need all the packages that you found in Lesson 5-2. So the Kern Lab especially, and also math. You don't need core plots so much at this point. Now, this information in lines 1 and 2 should look familiar for you. We're still using the SVM function, that's for support vector machines. The type is the same, all the stuff for the type is the same. We're still using the training data that we scaled in Lesson 5-2. But now for the kernel, we're using RBF dot instead of vanilla dot. That's the difference there. And so you can go ahead and train all this, and we're saving it as classify RBF, Control Enter, and it's done. It's pretty fast. Now we can check the results. Again, all this code should look familiar because we covered it in Lesson 5-3. And so we get the table here. You can see right there, that's our confusion matrix. So it's looking fairly accurate, and our overall accuracy is 81.15. But of course, I forgot to set my seed. So let me go ahead and do that for you so that we get consistent results here. So, okay, there we go. Still got about the same results, just about. And so now we can check the accuracy. You can see now it's a solid 82%. Now, in lines 9 and 10, we're just going to evaluate the model. So, excuse me, we're going to use the predict function. Right here, we're going to use our little model that we made, and we're going to use the testing data this time. And we're going to save it in something called the classify underscore predict RB underscore RBF. So we do that, and then of course now we take a look at our confusion matrix. You see, it looks pretty good. And then finally we calculate the performance, and you see we got 78.6, which is close to 82%. And like I've already mentioned before, the performance on the testing data is generally worse than on the training data because it's new information, it's new data. But it looks like our model generalizes well. Excuse me. So whether or not this is a good accuracy, whether or not this is adequate, depends on the purposes of your study and what you're trying to do with your model. If you need something higher, you would have to find ways to work with it. So for example, if somebody has diabetes but they're told they do not have diabetes, which happens, looks like about they have it but they're told they're not, right here, that might be a major concern, because if you are diagnosed with diabetes and you're not receiving treatment, it could be deadly. So you might want to try to reduce that again to where it's lowered, even if it means that more people are told that they have diabetes even though they do not, which is another common type of error when you're dealing with confusion matrices. So it all depends on what you're trying to do. So in this video, we pretty much explained and wrapped up how to deal with support vector machines for the purposes of classification. And all we did was we just tried a different kernel. There are many different kernels that are available. You can always look these up yourself. They're all right here in the documentation that you can view inside RStudio, and you can look at that and try to find different ways that you can improve your model. So my name is Darren Thomas. I'm the Director of Education and Research Techniques. This is easier. Practical applications of machine learning algorithms in R. Take care.